Hello student, today we are going to start our new topic, that is oscillation. Oscillation from class 11 physics. See, in oscillation we will study about what is time period. Yeah, periodic oscillation. What is that? Or periodic motion. She will say that it is that motion which repeats itself after particular interval of time. It is that motion which repeats itself after particular interval of time. Example will be rotation of earth on its axis, rotation of earth on its axis, revolution of earth around sun, motion of simple pendulum. All of these are periodic motion. Means these are those motion which repeats itself after particular interval of time. Then we will go for to and fro motion. What is that? Oscillatory motion. Oscillatory motion will say that it is that to and fro motion that repeats itself after particular interval of time. Example will be motion of simple pendulum, then motion of liquid in a U-tube, then motion of floating cylinder. These are all the cases where there is to and fro, back and forth, or we'll say that to and fro motion. Then we'll go for simple harmonic motion, SHM. What is that? We'll say that it is that motion that repeats itself after particular interval of time under the action of restoring force that is always directed toward the mean position. We'll say that simple harmonic motion is that motion that repeats itself under the action of restoring force that is always directed toward the mean position. In this case, what will happen is that we'll have force, restoring force, and that will be directly proportional to the displacement for the mean position. What is that? F is basically restoring force and X is what? Displacement from the mean position. Displacement from mean position. You will say that force is what? Minus K into X. And K is what? It is called spring constant. Now we will move on to the next topic, that is, it is very clear. First there is periodic motion. It is that motion which repeats itself after particular interval time. Then we have oscillatory motion. It is that motion which moves to or fro or back or forth about the mean position under the, and then we have SHM. It is that force which repeats itself after particular interval time, and it is always acting due to the restoring force that is always directed toward the mean position. See, a simple harmonic motion is represented by y is equivalent to I sine omega t plus phi. This is what? This is displacement of SHM. What is that? It is over here. Y is basically displacement. A is what? A is amplitude. Amplitude is what? It is maximum displacement of particle from the mean position. It is maximum displacement of particle from mean position. Then we have omega, that is angular velocity, that is equivalent to 2 pi nu, or it can be written as 2 pi by t. Over here, nu is what? It is frequency, that is number of oscillation made in 1 second, and t is time period. It is the time taken to complete one oscillation. Then we have phi, that is phase difference. It gives the exact location of the particle. Then we have velocity. What is that? Velocity of SHM will be what? We differentiate it out. See, what we'll get. This is a derivative of sine omega t is what? Cos omega t plus phi into omega. Then we have acceleration. What is that? It will be derivative of the velocity. Delta over here, what we have? This is with respect to t. Then over here we have delta v by delta t. It will be equivalent to what? A omega, already we have cos omega t is what? Derivative of cos omega t is minus sine omega t plus phi, then omega. It is coming out to be what? Minus omega square a sine omega t plus phi. What we have? Acceleration can be written as, acceleration maximum can be written as what? We will get the value of acceleration maximum when this is omega square. This is what? This is our y. It can be written as omega square y is what? Acceleration maximum. And for velocity maximum, what we will have? V max will be equivalent to omega into a, when cos omega t plus phi will become 1. V max is what? Omega a, and acceleration maximum is minus omega square y. Now we will go for total energy of SHM. See, total energy of SHM is basically, it is equal to the sum of kinetic energy plus potential energy. We know that y is what? This is a position vector a sine omega t plus phi. This is displacement basically. When we go for the derivative of it, it is coming out to be what? Delta y by delta t is what? A omega cos omega t plus phi. We know that kinetic energy of SHM is what? Half m v square, and we have what? Velocity is what? A omega cos omega t plus phi whole square. Then we'll go for potential energy. Potential energy is basically what? It is equal to the burden. Burden is what? It is equal to force into displacement. What we have? Force is what? It is equivalent to ky. This is delta y, and when we integrate it from 0 to y, it is coming out to be what? Ky square upon 2. What we have k as? See, we know that k is what? It will be force is what? Mass into acceleration, and we had mass is what? Acceleration is what? Omega square y. Then we have force is what? It is equal to k into y. This is coming out to be what? Ky m omega square y. This is what? K is what? M omega square. K is what? M omega square. This is what? M omega square y square by 2. And we know that y is what? We have, this is 1 by 2 m omega square. Y is what? A square sine square omega t plus phi. Now what we have? When we add this 1 and 2 equation, what do we get? This is total energy will be equivalent to what? Half. We have half m a square omega square is common in both kinetic energy and potential energy. And what is left out? What we have? We have cos square omega t plus phi plus sine square omega t plus phi, and it's coming out to be what? 1 by 2 m a square into omega square. This is what? Total energy of SHM. Then we'll go for we'll go for another format for velocity and acceleration, that is y is equivalent to a sine omega t plus phi. Let us suppose this is, we have velocity is what? Delta y by delta t. This is what? A omega cos omega t plus phi, which can also be written as what? A omega. This is what we have? 1 minus sine square omega t plus phi, and from here we will take out the sine omega t plus phi. That will be equivalent to what? A omega. This is what? Y square upon a square. This is what? A omega. This is what? A square minus y square upon a. This is getting cancelled out. What we are left with? This is omega a square minus y square. This is what? Velocity of a SHM. And for acceleration part, what we will do is that we know that acceleration is what? Double derivative of the velocity vector. What we have? Velocity as a omega cos omega t plus phi. Then acceleration is what? Delta v by delta t. This is coming out to be what? A omega sine omega t plus phi into omega. This is coming out to be what? Omega square a sine omega t plus phi, which can be written as omega square into, this is a sine omega t plus phi is what? Y, which can be written as this. Acceleration is what? Minus omega square y. See, we have to study two cases related to is that what is the velocity at mean position. So from this formula we can get the exact value of velocity at mean position. Mean position means what? Y is equal to 0. In that case, velocity will be what? Omega, this is y is 0, a square minus 0, this is omega into a. Then we have velocity at extreme position. What is that? It is coming out to be acceleration. Acceleration at extreme position is what? Sorry, we are getting for the mean position. And velocity at extreme position will be what? When y is equal to a, then in that case velocity will be 0. In that case, y displacement become amplitude. Then we have acceleration at mean position. What is that? See, acceleration is what? Minus omega square y. At mean position y is equal to 0, so acceleration is 0. Then we have acceleration at extreme position. Acceleration at extreme position. What we have? See, we have extreme position is what? Minus omega square y at displacement at extreme position is equivalent to the amplitude. So what we have? Acceleration will be equivalent to minus omega square a. Means directly we can get the acceleration and velocity when the position are given to us in the case of SHM. Now we'll be calculating the time period. Now we will be calculating the time period of the simple pendulum. See what we had calculated. We'll go for time period. See what we had calculated, that force is what? Force is equal to k into y, and force is what? It is equal to mass into acceleration, that is omega square y, and it is coming out to be what? K into y. This is m omega square y. See what we have? Y get cancelled out. We are left with omega square is basically equivalent to k by m. Omega is what? Root over k by m. Omega is what? 2 pi by t. That is equal to root over k by m. Time period is what? 2 pi root over m by k. Time period of any SHM will be quietly related to this. T is equal to 2 pi root over m by k. Over here we need to remember that m represent what? Mass, or we'll say that it is inertia factor. Inertia factor, and k is what? Spring factor or spring constant. See, let us suppose we have to find the time period of simple pendulum. In that case, what we'll do is that time period of simple pendulum. In that case, see what we will have to do is that, let us suppose this is the pendulum. Mass is this. Mass into gravity is acting downward. Let us suppose it makes angle theta with the vertical. In that case, let us suppose we draw the component of it. It is theta over here. This is what? This is mg cos theta, and this is what? Mg sin theta. See, we know that any SHM are supposed to have restoring forces. So, in case of simple pendulum, this is mg sin theta is basically the restoring force due to which the pendulum is returning back. That is the mg sin theta. This is the restoring force due to which the pendulum will return back to the original position. Let us suppose this is what? Let us suppose when angle is very small, this is theta, and let us suppose this is the circular part, and this is the this is the length of the pendulum. This is x. The length of the arc, circular arc, is what? Theta is equal to L by R. X by L. Theta is what? we have theta. Theta is equal to L by R. This is what? Length of the arc. That is basically length of the pendulum. X is what? The displacement along this. So in place of theta, what we can write? Mg x by L. And we know that force is what? Is equal to K into X. K is what? A spring constant. So we our spring factor. We equate them out. It is coming out to be what? Mg x by L. X can cancel out. K is what? Mg by L. Now what we'll do is that we'll place the value in this equation. Time period is what? 2 pi root over m by k. This is what? 2 pi m. K is what? Mg by L. Mg by L. See, this get cancelled out. What we are left with? This is 2 pi root over L by G. This is the time period of the simple pendulum. See, in any equation of SHM, this is the main important thing. This is common to every SHM. That is, time period is equivalent to 2 pi root over m by k. In every cases, what we need to do is that we have to find a spring constant or k of that part, and the rest will just place the value over here in place of k. Now we'll do the time period of liquid in a U2. Now we'll go for the time period of liquid in a U2. What is that? Time period of liquid in a U2. See, in this case, what we have, let us suppose this is our U2, and over there, let us suppose there is liquid. Certain liquid is there, and they are leveled. Now what we do is that we apply air pressure to it, and what will happen is that it descended by y along this. What will happen? The liquid will rise from this point by 2y, and as we know that time period is what? 2 pi root over m by k. M is basically what? Over here we'll take the mass of the liquid. That will be coming out to be what? Let us suppose this is the A is the area cross section of tube. Mass will be equal to what? L into A into rho. A is what? Area cross section of the tube. Rho is the density of the fluid. This is density, and L is the length of the tube from this to this part. And what has happened over here that we have applied the pressure over here, air pressure, due to which it has rose to the height of 2y. Then the restoring forces will be equivalent to what? Restoring force will be equivalent to 2y into A into rho into G. This is the force it will apply to come back to the original position. And we know that restoring force is also equal to K into Y. We equate them out. We will get the value of the K. This is 2y A rho into G. Y get cancelled out. K is what? 2 A rho into G. What we'll do is that we'll place the value over here. It is coming out to be what? 2 pi. M is what? L into A into rho. K is what? 2A into rho into G. A rho get cancelled out. What we are left with? 2 pi root over H by 2G. And let us suppose the length from here to here, that is equivalent to, let us suppose it is equal to 2h. Then what we'll do is that this is what? L. Now we have 2 pi, and let us suppose that L is equivalent to 2h. In that case, this becomes what? 2h by 2g. We are left with 2 pi root over h by g. This is the time period of liquid in a U2. And now we'll go for time period we calculate the time period of the floating cylinder. See, let us suppose in a liquid, let us suppose there is a cylinder and it is in equilibrium and it is at rest at this point. Means this is the mass, that is L into A into rho. This is rho is the density of the solid. This is density of solid. See, at this point it is in equilibrium position. Now what I am doing is that I am pressing it downward by distance y. This is the distance y. I am pressing it down, and now it has displayed certain amount of fluid. Then the mass of the fluid is what? It will be the mass due to which there will be restoring force. Restoring force basically equivalent to force is what? Mass into gravity over here. Y into A into, let us suppose the sigma is the density of the fluid. Density of fluid. In that case, Y into A into sigma. This is what? Volume, and this is density, and this is the gravity. See, we know that restoring force is also equal to what? K into Y. We equate them out. It is coming out to be what? Y into A into sigma into G. In this case, Y get cancelled out. K is what? A into sigma into G. Now, we'll place the value in this equation, and I had already said that it is common in all the cases. 2 pi root over m by k. Now m is what? Over here it is L into A into rho, and k is what? A into sigma into G. A gets cancelled out. We are left with what? 2 pi root over L into rho into sigma into G. This is the time period of a floating cylinder. Now we will go for calculating time period of a ball in a neck of air chamber. We will be calculating the time period of a ball in a neck of air chamber. See, in this case, what we have is that, let us suppose there is a cylinder. There is a cylinder which has like a cylindrical opening over here. What we have done is that we have placed a certain ball over here. Now it is balanced, but what we do is that, let us suppose we press it by distance y. So there will be change in the volume, that will be equivalent to area of cross section of this part opening into y. This is what? Change the volume. What will happen is that earlier on it was at rest. What I have done is that I have compressed it to a certain level, due to which there is change in the volume. Now we know that time period is what? 2 pi root over m by k. See, what we do is that we know that bulk modulus is what? Force upon area into change in volume upon original volume. Now see what will happen. We know that force will be equivalent to what? V into A into delta V upon V, and we know that delta V is what? A into Y. The V into A into Y. That is what? V. This is what? V into A square Y upon V. This is what? Force. And we know that force is also equal to K into Y. We have to calculate the restoring force and the spring constant. See what we get? K is equivalent to what? VA square by V. Now what we'll do is that we'll place the value over here. That is 2 pi. This is M. This is coming out to be what? VA square V. Or we can have like, this is 2 pi root over M into V. We can take the A outside, doesn't matter. And this is bulk modulus. This is what? A time period of a ball in a neck of air chamber. And there are few smaller topics like what is like damped oscillation, forced oscillation, and resonance, and there are few topics related to it which we can do in the next class. Thanking you. All the best.